All right, let's dive in. Today, we're talking about a role that is absolutely at the core of how things get made, the Proto design engineer. These are the people who take a cool idea and figure out how to turn it into something real, something you can actually hold in your hand. Seriously, think about it. Your phone, your headphones, even the chair you're sitting in, every single one started as just an idea in someone's head. So how does a concept go from a sketch on a napkin to a product on a shelf? Well, that journey starts with a very special type of engineer. You can almost think of them as modern-day inventors. They are the essential link, the one that connects the world of pure imagination to the nuts and bolts reality of a factory floor.
Okay, so what's the official definition? A proto design engineer is the specialist who creates the very first working versions of a product. We call those prototypes. And they don't just design them, they also have to coordinate the whole entire process of getting them built.
I think this is the perfect way to picture it. They literally build a bridge from a hypothetical, what if we made this, to a tangible, real, here it is. It's a role that demands this really cool mix of creative, out-there vision, and super focused technical skill.
So how does this all get started? Well, before any metal gets cut or any plastic is molded, the entire product has to exist perfectly inside a computer. This is the first absolutely critical step, creating the digital blueprint. The whole workflow usually starts with concept models. Think of them as rough digital sketches. From there, it gets way more detailed with 3D CAD modeling, creating a complete virtual version of the product. And finally, all that amazing 3D information gets translated into precise 2D drawings. Those drawings become the official instructions for actually making the thing.
Yeah, this is not a pencil and paper job anymore. Engineers use these incredibly powerful software programs. You might hear names like CATIA or AutoCAD. It's basically a virtual workbench for the 21st century inventor, letting them shape every single detail with insane precision. But here's the thing. That digital model isn't just a pretty picture. It's a precise engineering document. To create it, engineers have to master concepts like GD&T. In simple terms, that's a universal language of symbols that tells a manufacturer exactly how flat or how round or how angled a part needs to be. It takes away all the guesswork so every single piece fits together perfectly. So, once that digital blueprint is finally done, the job is far from over. Now the engineer has to switch hats, going from being a digital designer to a hands-on project coordinator to bring that computer file to life.
And this really gets at the next big challenge, right? A perfect 3D model is totally useless if you can't actually build it. This next phase is all about teamwork, communication, and, logistics.
A proto design engineer isn't typically building the prototype with their own two hands. Instead, they act as the central hub, the main coordinator. They're talking with specialized workshops, ordering parts from all kinds of different vendors, and working with the manufacturing teams to make sure everyone is on the same page, following that blueprint perfectly. And to keep this incredibly complex process from falling apart, they manage a crucial document called the Bill of Materials, or BOM. Just think of it as the ultimate shopping list, detailing every single screw, wire, and tiny component needed for the build. It's a huge organizational job. All right, all of this design and coordination, it all leads to the most exciting and, let's be honest, probably the most nerve-wracking part of the process. The moment of truth has arrived. It is time for testing.
After weeks, maybe even months, of design work and phone calls and planning, all the individual parts finally come together. For the very first time, the new product is a real, physical object. This is the big question, isn't it? Does it do what it's supposed to do? Can it handle real-world use? Did all those pieces fit together exactly the way they were planned on the computer screen?
And you guessed it, the engineer's job still isn't done. Now, they have to work side by side with the testing teams, putting that prototype through its paces, pushing it to its limits, and carefully writing down every single result, the good and the bad. You know, in this process, failures aren't just expected, they're actually really valuable. The feedback from testing, what broke, what didn't fit, what could be better, all goes straight back to the design. This creates a cycle of improvement, called iteration, that makes the product better and better with each loop, and it saves a ton of money on costly mistakes down the road. So, what does it actually take to become one of these architects of innovation? Let's take a quick look at the kind of skills and qualifications you'd need for this role. The foundation is almost always a bachelor's degree in a field like mechanical, automobile, or production engineering. And that degree is typically coupled with at least a few years of real, hands-on industry experience.
And it's probably no surprise that this role is found smack in the middle of a company's research and development, or R&D department. This is the engine room of innovation, where the future is literally being designed and built.
At the end of the day, that is the perfect way to sum it all up. A proto design engineer is an architect who doesn't just dream up new ideas, but also creates the detailed blueprints and oversees the construction of the very first one.
And that leaves us with one last thing to think about. Just take a look around you, right now. The mouse in your hand, the lamp on your desk, the car in your driveway. Almost every single manufactured object you see started its life as a digital file on an engineer's computer, a bridge they built between what if and what is.